Okay, welcome to Unit 2. We're going to be looking at relations and functions to start with. Relations can be represented in all these ways, but the main thing is that a relation is a set of ordered pairs. So we can actually write them in ordered pair form. Okay, we could write those same ordered pairs out in a table, like shown here. We could take those ordered pairs and graph them, so we can look at it graphically. One last one is mapping one value to another. So all these ways can be represented the same way. A function, what we say then, is a relation, what we were just talking about, where each input has a single output. All right, this right down here is function notation. And just kind of each part of this, the f in this is the name of the function. Okay, so f is our function name. What's inside the parentheses x, that's the input of the function. This is also what's going to get plugged into the function. Okay, it's going to be what gets plugged in. This whole thing, the f of x, that is called, that is the output of the function. And then what comes after the f of x, what it said equal to, that's the rule used by the function. And I'm going to call it for right now the function machine, as we'll see in a little bit. Is basically it's going to take your x value and do something to it. Now, what you should know is when you're doing this, when we say f of x equals 3x plus 4, that's also the same as y equals 3x plus 4. Okay, f of x is just another way of writing y. It's just showing your function is instead of y is going to be f, and it shows what the input variable is here, x. Okay. So how functions work? A function is kind of like a machine. It takes whatever the rule is and does that to any input. So in this function, our rule is 3x plus 4, taking whatever the x value is, timesing it by 3 and adding 4. So if we are going to find what f of 2 is going to be, we're going to plug 2 into the machine, see what we get, and solve that out. So if our rule is 3x plus 4, what's that going to do? It's going to take 3 times 2 and add 4. That's 6 plus 4. So what comes out then is 10. So if you plug 2 into this rule, out comes 10. Similar, if you would find f of negative 1, that's putting negative 1 into the same rule of 3x plus 4, and what we're going to get is 3 times negative 1 plus 4, or multiplying, we get negative 3 plus 4, which is positive 1. So if you put negative 1 in, you get 1 out. How we would write that in function notation would be that f of 2 equals 10. Because when we plugged 2 in for our x value, out came 10. We could also write that as an ordered pair of 2, 10. So all these things mean the same. But with our second example, when we plugged in negative 1, out came 1. So that's also saying there's an ordered pair of negative 1, 1. Okay, when is a relation a function? A relation is going to be a function if it passes what's called the vertical line test. So if you can draw a vertical line that intersects the graph no more than once, then you have yourself a function. Um, what's that? What another way of saying that is you can't have, or there should be no repeated x values. Because if you have a repeated x value, that means that x goes to two different y's. And in a function, we should always know if you plug in something, like if I plug in 1, I should only get one number out. There shouldn't be two choices that 1 can equal. Otherwise, we don't know what f of 1 is. If it can be two different values, that doesn't work. That's not a function. All right, so let's check some different examples and see if we can find out if it's a function or not. Okay, so this first one, okay, in a mapping situation like this is your x being mapped to your y's, or f of x's. Okay, do we see any repeated x's here? No, so this mapping would be a function, because we could write all these out in function notation. It's okay that both of these go to 0. That's just saying f of -1 is going to equal 0, and same with f of 3 equals 0. It can equal the same one. It's just that we can't have the same x value equaling two different things. All right, let's look at B. Here's a table now. Is this a function? Well, let's look at our x values. Do we see any repeats? Ooh, yes, we do. So this one is not a function. Because if I ask you what is f of -1, we don't know. Is it 2 or is it 4? There's two possible values there. That's not a function. In a function, you should always know exactly what the function, with an input, we should know exactly what the output should be. C, this one doesn't have any ordered pairs like before. So here's where we want to go on with our vertical line test. If we draw a vertical line, does it pass through the graph more than one time? Yeah, it does. This vertical line hits the graph twice, so then this is not a function. Because of that same situation we talked about before. This ordered pair and this ordered pair, we're not really sure what these values are, but the x value here is going to be the same as the x value down there if it's on the same vertical line. Can't have the same value in both. D, if we look at these, do we have any repeated x values? No, so this would be a function. Okay, so anytime you have the, oh, sorry, this last one is not a function. My mistake. Not a function. And we don't have the repeated x values, like I said, but if you look here, 2 goes to multiple things. You can't have 2 going to two different values, otherwise that's not a function for the same reason. Is f of 2 equal to 2? Or is f of 2 equal to 3? There shouldn't be any question. So you can't have an x on this mapping thing. You can't have an x having two lines coming out of it. It only should have one line coming out. So this one was not a function. Okay, looking at some problems with function notation then. If you're given a function, in this case g, and they ask you to find what the values are, simple. Just do what we did before. Input this value of x in for all the x's and see what you get. So here we want any x in this one, this right here and this right here, become 2's. And then it's just simplifying that out. Now just follow order of operations, what we talked about before. Parentheses are simplified. There is an exponent here, so that's what we should start with. 2 squared is 4. Now do the multiplying, you get 6 and 8. Simplifying, you get -2. You could also just do that with your calculator and help you solve it out that way. B, we got g of 3 times g at -1. So what we want to do in this case is find both of these out, and then that's telling us to multiply the results of both functions. So if we find g at 3, by plugging 3 in into that same function. That's going to come out to be 9 minus 2 times, we got to square first, 9. 2 times 9 is 18. That's going to equal negative 9. So this one equals negative 9 times, now we got to figure out what's g at negative 1 going to be. So using the same function and now plugging in negative 1. And again, these could be done with calculator. Squaring a negative is still going to make this be positive because negative 1 times negative 1 is still 1. Now doing our multiplying, we get negative 3 minus 2, which is negative 5. And so that's negative 5. If we times these two values together now, the answer would be 45. All right, C. Now we're given a function. Our input is 3x. And so here what we want to do is, again, same function. Even though it has an x in there, we're still inputting whatever's in that parentheses in for our input variable, which is x. So now our x's become 3x's. Okay, and now you just go through and try to simplify again as much as possible. We're not going to be able to simplify this one down to a number, so we just try to get it as simplified as an expression as we can. I always start with exponents, so if we take 3x and square it, 3x times 3x would be 9x squared. Okay, now let's do our multiplying. 3x times 3 is going to be 9x. 2 times 9 is going to be 18x squared. These are not like terms. We can't subtract them, so that's as far as we can go on that. That would be the most simplified expression we could get. All right, these next problems want us to take different functions and evaluate them at each of the variables. Okay, so now you got to be a little bit more careful at looking at what function we're looking at, because there's different function names here like g and f, so you want to make sure you're going to the right function. So if we're going to find g at 10, find the g function and drop in whatever that input is and see what the output comes out to be. So here we got to do with multiplying first, add, and looks like we get negative 29. Okay, why don't you pause the video and see if you can do b on your own. All right, let's see what you came up with. On this one, you're using this function now. So you got your input squared plus 7. That's 9 plus 7, or you should have ended up with 16. Okay, C, again, doing the same thing, looking at what this is and inputting it. You got this function. So we got 12 over our inputted value of negative 2. 12 divided by negative 2 would be negative 6. Okay, looking at the other 3 on there, j at 7. Okay, now we're over to this function over on the right. Okay, drop in 7 there. So you got 2 times 7 plus 9. That'd be 14 plus 9, so the output is going to be 23. Now on E, now it starts being a letter here. It's a different letter. It's not a number, but the process is the same. Look at where the function is, and then drop in that variable. So here's H. Okay, so H is 12 over our inputs changing from X to A. We can't really divide 12 by A because it's a variable, so then we just leave our answer as 12 over A. F here is kind of similar, so now they want us to use function G again. Okay, now wherever there's an X, they want us to input B plus C. So if we're inputting B plus C in for X, it would look like this. Other than multiplying both of these, there's not much we can do here. So the answer would be negative 3b minus 3c plus 1. None of those are like terms. That would be the expression for this function. All right, last ones. These ones now are kind of giving us the information the other way. So here it says find x if g of x equals 16. So what they're telling us on this one is we know what the final output's going to be. This is our output. So what we want to do is substitute that in for the output and see what the input's going to be. So now we got 16 equal to what our function does. If we solve this, we can find the input. So now you're just working backwards here. Subtract 1. Divide both sides by -3. And our input then would be -5. So when the output 16, the input would be -5. That means this is function g. Function g at -5 equals 16. It would also tell us there's a ordered pair at -5, 16. All right, let's try another one here. H. Okay, find x if the input is, find out x if the output is -2. So it's very similar. That's our output. If we put that in for the output, what do we get for the input? So -2 equals 12 over x. To solve that one, we could let's get rid of our fraction by timesing both sides by x. Okay, so now we have -2x on this side equals 12, because these would cancel out. Divide by -2, and it looks like our answer is -6. All right, why don't you pause the video and see if you can solve I. What would the input be if the output is 9? Okay, let's see what you got. So function j on this one is equal to 2x plus 9. So if our output is 9, what's our input? Solving this one, if you subtract 9 from both sides, that's going to be 0. If you divide by 2, if you divide 0 by 2, it's still 0. The input would be 0. So that's telling us j at 0 equals 9. Okay. All right, last example. This one is saying swine flu. There's swine flu attacking Porkopolis. The function below determines how many people will have swine flu, where t is in time in days and s is the number of people in thousands. So that's what this function right there is telling us. First part says find s at 4. Just like the problems we were just doing, s at 4 would be 9 times 4 minus 4. That's 36 minus 4, which gives us 32. Okay, what does s of 4 mean? Remember, s is the number of people in thousands that have this flu, and 4, our input, is time in days. So what that's telling us is after 4 days, because that's our input, we get 32, but that's in thousands. So after 4 days, then 32,000 people have swine flu. Okay, so that would be what that is saying. All right, C. Find t when s of t equals 23. Okay, so this is kind of working backwards again. We know our output. What was the input? Okay, so if we take 23, put it in for that, what do we get? So we get 23 being equal to 9t minus 4. Work backwards, add 4 to both sides. Divide by 9, and we get 3. So what does s of t equals 23 mean? Okay, so that means our time is 3. So after 3 days, 23, remember this is in thousands, so 23,000 people have swine flu. All right, last part, they want us to graph this. So if we go over on the graph now, we got 2 points. We should be able to look and see what the graph is doing. We have this point here of 432. Okay, so at 4, we would have the value of 32, and our graph doesn't, our y-axis doesn't really work with what we got here. So let's just say that this is going by, instead of ones, like 10, 20, 30, and so on. And so this would be negative 10, negative 20, and so on. So if we put these points on there, we got the point 4, 32. 1, 2, 3, 4, 32 be about there. If we graph the other one, we got 323. So that would be around here. So now if we connect these, we should get something like that. And again, we can use our function here. The slope of this line would be 9, and the y-intercept should be at negative 4. So that would be the graph of this one. All right, try some of these out then on